a ohm is electrical proportional to the, we'll take it, we'll get an equation V is equals to IR and R is by and rho, this resistance as well as these. Now V equals to is normally what will be R1 L rho 1 by then of different length we do, it will be L1 get. We'll talk about stretched conductor or stretched wire. Okay, this is the conductor and this is a rho. It is independent of area. So and A2 the is not changing. Okay, changing one. What if we make the for this volume A1 to L1. So we know at this time we are talking L square, and also here by substituting area L1 by L2 is equals to A2 by A1. No, so R1 by R2 is equals to A2 square by A1 square. Here we can conclude that is equals to R1 is proportional to R is proportional to 1 by A square. R is inversely proportional to A square, we can say. These two are important results we got here. Important results. We'll do a sum on Ohm's law now. We'll do a numerical on that. And also guys, my notes will be provided in the description, updated shortly. Will be updated nearly 5 days. In that it will be updated. My handwritten notes. Okay, I'll write that sum here. This I got from that H. Verma Singh's, I think. Sorry, I forgot from where I got. Determine the resistance. Kindly answer it from the in live chat. Resistance. Determine the resistance of hollow cylindrical wire of length L length L and radii as shown, and whose resistivity is rho. So, and this is the diagram I am drawing here. Okay, this is the diagram, and see, wait, I'll write here. Answer by R, and this here rho L by 6 pi R square and rho L by 7 pi R square, and also rho L by 4 pi R square. Give me the answer in live chat. This is the question. What is the question is? the resistance is, see the resistance, guys, the resistance is, determine the resistance of the hollow means here this is containing of air, this is air, cylindrical wire of length L, this is a wire, this is here, this is hollow means this is hollow space is radius r, and for this one is 2r. Okay, the resistance is rho. The resistance is rho. These are the options. Give me the answer in the live chat now. Kindly share the video, guys, for how many as possible. Kindly share the video. Did anyone got the answer? Say the option, please. Sorry, this is the option written wrong. Okay. Say the answer. Kindly. Quick, please say the answer. Did anyone got it? It seems that anyone didn't got. Okay. No one is keeping answer. No one kept answer in the live chat. Okay, I'll say the answer. C. Solution. This one. No one didn't got the answer. No one. Okay. R. What is the what is the R? Resistance formula is rho L by A. Rho L by A, and this R is equal to okay, rho L by this one area. We'll neglect this area because this is not conducting electric current, that is hollow space, no electric current will be passed through it. So the current will be passed through the metal wire. We'll take that hollow space and we need the space which we need. So this rho L by A will take this hollow space from this total space, and this is equals to R is 2, no, 2R, R is 2R, R2 is 2R, something. This, what is the area of that cylinder? 2R, okay, pi r square, means cross sectional, that is not the area of cylinder, sorry, that r1 square. So here R is equals to rho L by, here we will get 4 pi r square, and here we will get pi r square, and the answer is rho L by 3 pi r square. And some numericals will be done in this. I'll say about that sessions. I'll conduct those. I said no. I'll say them also in live. Okay. Now, Ohm's law. V versus I graph. V versus I graph. See, I already said that this will be linear, means this will be straight line, because that this is x and this is y. Okay, the R, this is resistance graph, no, resistance graph, V versus I graph. This is V and this is I. This is V and this is I. Okay, this is going, that is constant. This is constant. This is constant line. I already said about it. That is constant line. At that, the slope will be constant because it is at a fixed point. We know that already. We have discussed about it. That is constant, and it is equals to tan theta. Here the slope is y by x is equals to tan theta. and that y by x is v by I is equals to tan theta, and here tan theta is r. This is the Ohm's law, V versus I graph when it is following the Ohm's law. Okay, we'll take now non-ohmic law when it is not following the Ohm's law. When it is not following the Ohm's law. See, when it is following the Ohm's law, that slope is constant, r is equals to v by I, we will get the slope. Okay, and non-ohmic law, we will get that this is not at non-ohmic law means it is not, we can't say that it is following semiconductors like that, because semiconductors will be another thing that will I'll discuss in the next session. A small graph, only graph we'll discuss about it. Okay, now non-ohmic law means it is going like this. Then at any two points, here the voltage is delta V, difference, and the difference in electric current is delta I. So the slope is not constant, means that is, no non-ohmic law means not following Ohm's law. Ohm's law is not followed. Ohm's law not followed means slope here is delta V by delta I, and when it is when we'll take it as limit delta t tends to 0, then what happens is delta V by delta I. Here we will get dV by di. dV by di, we will get that slope. So that is not following V by R. V is equals to IR. Law it is not following, means non-ohmic law. That is a simple thing. Okay, and also we now we will discuss about temperature dependence on resistivity. Temperature dependence on resistivity. Temperature dependence on resistivity means here we this is not a derived one. This is experimentally we got that. That is the scientist did an experiment and he got that, but it is not derived. So directly, this is the equation. Resistivity. We'll talk now about resistivity starting. Now I'll explain the terms in this one. Okay. This is the equation we'll get, means this rho is equals to rho naught into 1 plus alpha delta t. Here rho is the resistivity at when the temperature is increased. Okay, temperature is increased. Wait, once I'll say one thing, small thing. Here see, when we'll talk about it. One small thing I forgot that we should say now. I should say now. See, when the conductor, that is also temperature dependence. When the conductor is normal at normal temperature, like 0 degrees, means 0 to 20 degrees, at that temperature, 0 to 20 degrees Celsius or 27 degrees Celsius, at that temperature the V Ne square conductivity sigma Ne square by Ne square into tau by m, and this one also, that rho is also this m by Ne square tau. Okay, here when it is normal temperature, at normal temperature at T1 we'll take, at this temperature what happens is the electrons do random motion, but it is normal, means if that is, it will be normal, that won't change, that no effect, how much it will be concentrated, it will go like that. But when the conductor is heated, the temperature is increased, the positive ions, due to that temperature get increased, the it will go under thermal agitation, the positive ions will get vibrated, means the atoms in that metal, the positive ions will be get vibrated due to that thermal agitation, thermal energy, means one kind of thermal energy is released. Due to that, the thermal velocity takes place, the thermal velocity will be increased more in that electrons. Here the collisions will be at normal rate, but here the due to that thermal agitation, the velocity will become more of that electrons, and that will takes place continuous collisions, continuous fast collisions, frequent collisions with those positive ions. Due to that more collisions, the relaxation time tau is decreased, means average collision, average time between any successive collisions, any number of successive collisions, this tau will be decreased. Due to that decrease in that tau, this velocity will be also decreased, drift velocity will be also decreased, and here this conductivity will be also get decreased, but this resistivity will get increased. Okay, resistivity get increased. Understood the point? This is an important one. Okay, means now this is also temperature dependence, on resistivity. Now we'll talk about this resistivity now. Okay, here what is the thing is the temperature dependence on resistivity. When the temperature, means we got this equation. I forgot to write. Okay, this rho is at a norm when the temperature is increased. Resistivity when the at temperature increase, at that temperature we'll take as T. Okay, T, and rho naught is temperature, resistivity at normal temperature. We'll take T naught, means 0 to 20 degrees Celsius, it will be the normal temperature, will be taken in the numericals, means in the sums will mostly they'll give that 0 to 20 degrees Celsius, mostly they'll give that. And this alpha is coefficient, means it's a not constant, it's like a coefficient of temperature, we'll do numericals on this. I'll do an example, some example sums in the next session. In DPP, those sessions we'll do that sums on this. Okay, numericals. It will be they'll be interesting. Okay, and this delta T is the change in the time. That is T minus T naught. Thank you, Deepak. Hi, TV Subbarao. It seems hi, and this delta T is T minus T naught. Okay, and that is the thing. Okay, now we'll find the alpha. These are the terms on it. Okay, we got this equation. These are the terms on it, and here now what we'll get, the rho is equals to rho naught plus rho naught into alpha by into delta t, and here we will get rho naught rho minus rho naught by rho naught is equals to alpha into delta t, means this is transferred this side, and this rho naught is that is also transferred this side, and here we will also transfer this delta t, and we will also transfer this delta t. This we will get the alpha. This is alpha, temperature coefficient. Still we will get, wait, this alpha is equals to the, no, change in the resistivity is delta rho. We will take delta rho by rho naught into delta t, and this is the resistivity. We got this. Okay. In the case of resistivity, that when it is depending upon, means the temperature is slightly increased or heavily increased, means at a normal nearly 5 to means here the 5 to 10 minutes, it is, means sorry, 5 to 10 degrees Celsius, or still more it is increased, the change in that is, the change means then we will get the resistivity is equals to rho naught into 1 plus alpha delta t, and the terms are alpha is temperature coefficient, delta t is change in temperature, and this rho naught is at the temperature, at the normal temperature, means reference temperature, and this rho is at that when the temperature is increased, the rho is the resistivity. Now temperature dependence when it is on resistance. So here what we'll get is R. Similarly, because this R is proportional to rho, so we will get the similar equation, a similar result, that is R is equals to R naught into 1 plus alpha into delta t. Same, no, just the resistance has changed, the term is changed, which is taken, that is resistivity and this resistance. Okay, here the alpha, here the R is when at a temperature, R is resistance at when at temperature increased, when the temperature is increased, T, we'll take that as T, and this R naught is resistance at T when T at normal temperature, the reference temperature when we have took that. So here this alpha is similar, same coefficient of temperature, and this delta t is T minus T naught, that is change in temperature. Okay, the similar one, just that R is here, we will take the resistance, all are similar, rest all terms are will be similar. Okay, now here we will get the alpha R minus R naught. Okay, normal we write, I went up here. Okay, here delta t into R naught, here R minus R naught. Okay, R minus R naught, we will get here, that is R minus alpha is equal to R naught into alpha t, delta t. Here that will be alpha is equals to R minus R, that will take as delta R, will take, means R minus R naught will take as delta R, that, so alpha is equals to delta R by R naught into delta t. This is the temperature coefficient. Okay, that is the temperature coefficient. Alpha is equals to delta R by R naught into delta T. Delta T. Okay. This is the when temperature dependent on at the temperature dependent case. This is the thing we have got this. We have derived these all, not derived. We got this experimental data from that, and also we can say that when R1 is equals to R naught into 1 plus alpha delta T, means this is numericals. At that case they will give like this, R2 at two cases delta T, or at this temperature is T1 and this temperature is T2. Here the and 1 plus alpha T1 by 1 plus alpha T2. Okay, and here alpha will be, means similarly we will get alpha will be R2 minus R1 by R naught into delta T. Okay, at the numericals he will give like this two equations. That will also we can do like that, but for clarification I said this one. And another will be when the graph is starting from some extent like this. At that time it will be, at that time the R will be R naught into 1 plus R, or that we can take that R or that resistivity rho. Okay, plus 1 plus alpha T, alpha delta T plus beta delta T square. Beta right here. R is equals to R naught into 1 plus alpha delta T plus beta delta T square. This will be R is equals to this, and similarly we will neglect that delta T square, so we will get again 1 plus alpha delta T. These are some exceptional cases. Means exceptional means when the parabola is taken at some extent that when it is starting from that. And today we got some, and today we have discussed these numericals and the last topic recalled about last session, and also R is proportional to L square. R is proportional to L square, and R is inversely proportional to A square, area square, cross sectional area whole square. That is that one we have derived. And next one, the graph, means problem also we have derived some other those problems. You can rewind it and you can see. And we have discussed about this graph, V versus I graph. At that time we got tan theta, the slope is equals to R, we got V by I. And next non-ohmic one, and that is dV by di, we got the slope, the tan theta. And next we got this rho, means resistivity, temperature dependence. At that time I also said rho and this sigma, both are depending upon the temperature. Okay, both are depending upon the temperature and pressure. So rho is equals to, means rho at some temperature when it is increased is equals to, rho is equals to rho naught is the normal temperature, reference resistivity. Rho is equals to, means at the temperature dependence on the resistivity. Then rho is equals to, we got that rho is equals to rho naught into 1 plus alpha into delta T we got. And another one at temperature dependence on the resistance, R is equals to R naught into 1 plus alpha delta T. And alpha at the starting case we got alpha is equals to, means at resistivity, delta rho by rho naught into delta T, we got that one. And next resistivity, at that time resistivity we got alpha delta R by R naught into delta T. Okay, these are the concepts we have discussed today. If you like my explanation, kindly like, share and subscribe to my channel.